Assalamualaikum to Puan Rosmawati for our network design lecturer. So today my group want to present about problem-based tasks. So my name is Muhammad Hidayatullah bin Ibrahim and this is my group members. Given is Cempaka Enterprise Company's network has been enhanced. Each of the departments got many of new hires in order to solve the network problem and increase the network ability. The director make the decision to hire you as a network designer. And then figure 1 shows the company layout. So as a network designer, we need to design some new upgrades for the company, which is company's enterprise, so that the company will have more flexibility of network. This paragraph, I just want to summarize that us as a network designer, we need to design a hierarchical network architecture, and then we need to know the IP addressing and create equipment list to meet internet network requirements. So we need to have the IP address of 172.116.10.0/24 networks. So we need to place the hardware and the device accordingly so that it will look more appropriate for the CEO to know the design of this network. Also, we need to create project timelines that what software and hardware that we use, and then we need to test the network using simulation tools such as Packet Tracer. This is the summarization for our customer. So to know that we as a network designer from the company Cempaka Enterprise is small to medium office that has 7 functional areas such as programmer department, manager room, WC, server room, technical support department, accounting department, and sales department. So we need to build a three layer design that is from core, distribution, and access layer using the given IP address. So after we design the network, I will next explain the network requirement to set up the new network. So we need to do VLAN and then inter VLAN on the switch, and then we need to assign IP address and assign DHCP protocol to the device so that it can provide communication with other device. Also, we need to do a HTTP server, and we need to do VLAN segmentation. So that's the thing to do after we design the network. So here are the IP address for the addressing table for each department. I will not explain much about this. So here is. So this is the continuation of the IP addressing table for all the device from router to switch to server, printer, and others. So here, as you can see, this is the logical and physical topology for the requirements of the company. So there are 7 departments, and each device are put accordingly. And you can look at this diagram at here. Next, I will summarize this, the type of cable used and network hardware appropriately, and then the suitable software for monitoring network and HTTP server. So we need to use the right cable to make sure that we connected with the if we connected with the wrong cable, we will have we will not get the result as we think. So this are the summarization. Continue with the configuration for the device, starting with the router configurations. As you can see here, we need to configure the device name R1S1, and then we need to configure the interface, which is gigabit internet interface G0/1. For this router configuration, I will not explain much because as you can see here, this is the basic configurations for the router, starting from giving the host name and then the no IP domain lookup and all the way down until we assign the IP address to the interfaces.
Interface G0/1, no IP address, no shutdown. Interface G0/1.50, encapsulation.1Q50, IP address 172.16.10.225, 255.255.255.248, exit. Interface G0/1.60, encapsulation.1Q60, IP address 172.16.10.233, 255.255.255.248, exit. Interface G0/1.10, encapsulation.1Q10, IP address 172.16.10.1, 255.255.255.128, exit. Interface G0/2, no IP address, no shutdown. Interface G0/2.30, encapsulation.1Q30, IP address 172.16.10.161, 255.255.255.224, exit. Interface G0/2.20, encapsulation.1Q20, IP address 172.16.10.129, 255.255.255.224, exit. First, IP routing, then there are various IP DHCP excluded address. Next, IP DHCP pool sales, network 172.16.10.128, 255.255.255.224, default router 172.16.10.129, DNS server 8.8.8.8, exit. IP DHCP pool accounting, network 172.16.10.160, 255.255.255.224, default router 172.16.10.161, DNS server 8.8.8.8, exit. IP DHCP pool programmer, network 172.16.10.192, 255.255.255.224, default router 172.16.10.193, DNS server 8.8.8.8, exit. IP DHCP pool tech support, network 172.16.10.232, 255.255.255.248, default router 172.16.10.233, DNS server 8.8.8.8, exit. IP DHCP pool manager, network 172.16.10.240, 255.255.255.248, default router 172.16.10.241, DNS server 8.8.8.8, end. Build the prototype based on the logical diagram and complete the configuration. Switch configuration. Configure the device name S1_S1. Configure the device name S2_S3. Configure the device name S3_S4. Enable configure terminal, hostname S1_S1, no IP domain lookup, VLAN 40, name programmer, exit, VLAN 70, name manager, exit, VLAN 99, name MGMT, exit, interface G0/1, description link to R1, G0/0, Switchport mode trunk. Switchport trunk allowed VLAN 40 70 99. Switchport trunk native VLAN 99. No shutdown. Exit. Interface range FA0/2 to 4. Switchport mode access. Switchport access VLAN 40. Spanning 3 port fast. Exit. Interface FA0/5. Switchport mode access. Switchport access VLAN 70. Spanning 3 port fast. Exit. Interface VLAN 99. IP address 172.16.10.249. 255.255.255.248. No shutdown. Exit. IP default gateway 172.16.10.249. End. Enable configure terminal. Hostname S2_S3. No IP domain lookup. VLAN 10 name Wi-Fi. Exit. VLAN 50 name servers. Exit. VLAN 60 name tech support. Exit. VLAN 99 name MGMT. Exit. Interface G0/1. Description link to R1 G0/1. Switchport mode trunk. Switchport trunk allowed VLAN 10 50 60 99. Switchport trunk native VLAN 99. No shutdown. Exit. Interface FA0/2. Description HTTP server. Switchport mode access. Switchport access VLAN 50. Spanning 3 port fast. Exit. Interface range FA0/3 to 4. Switchport mode access. Switchport access VLAN 60. Spanning 3 port fast. Exit. Interface FA0/5. Description wireless router WC1. Switchport mode access. Switchport access VLAN 10. Spanning 3 port fast. No shutdown. Interface VLAN 99. IP address 172.16.10.250. 255.255.255.248. No shutdown. IP default gateway 172.16.10.249. End. Enable configure terminal. Hostname S3_S4. No IP domain lookup. VLAN 20 name sales. Exit. VLAN 30 name accounting. Exit. VLAN 99 name MGMT. Exit. Interface G0/1. Description link to R1 G0/2. Switchport mode trunk. Switchport trunk allowed VLAN 20 30 99. Switchport trunk native VLAN 99. No shutdown. Interface range FA0/2 to 4. Switchport mode access. Switchport access VLAN 30. Spanning 3 port fast. Interface FA0/5. Description accounting printer. Switchport mode access. Switchport access VLAN 30. Spanning 3 port fast. Exit. Interface range FA0/6 to 8. Switchport mode access. Switchport access VLAN 20. Spanning 3 port fast. Exit. Interface VLAN 99. IP address 172.16.10.251. 255.255.255.248. No shutdown. IP default gateway 172.16.10.249. Build the prototype based on the logical diagram and complete the configuration. Wireless router. Set up wireless router for WC area. Configure the internet connection type and SSID. Wi-Fi_WC1. All the staff's devices can connect to the wireless network by obtain IP from DHCP. These are the wireless settings: SSID, Wi-Fi_WC1, authentication, WPA2-PSK.
The prototype based on the logical diagram and complete the configuration. So this slide explains how to configure IP address for all PCs and printers. Each device must be given a valid IP, subnet mask, and default gateway based on the addressing table. And this step ensures every device in the network can communicate properly. This shows how laptop and smartphone connect to the network using Wi-Fi. They receive the IP address automatically from the DHCP-enabled wireless router. The WPA to password Cempaka Alliance 2025 secure the wireless connection. Here we assign an IP address to the web server and create a company web page called Cempaka Enterprise. Uh, the web page confirms the server is working when accessed to a web browser using the server's IP address. Site test network connectivity. The manager PC successfully pings all the device, proving the network is connected and configured correctly. The programmer PC also pings every device successfully. This confirms that communication between departments works without any issues. The server pings all the other PC successfully. It confirms that the server is properly connected and reached by all users. Just port PC is tested next and all ping results are successfully. This shows reliable connection across all devices in the network. Sales PC test shows successfully communication with all other devices. It ensures the sales department has full access to the network resources. Accounting PC test is done and all pings succeed. This proves that the entire network is stable, fully connected, and function as designed. This stage, we test our prototype network to make sure it works as planned. Here, I connect a laptop to the wireless router using Wi-Fi, just like how staff would connect their own device in a real situation. The purpose is to verify that the wireless connection is working properly. And you can see in the command prompt window that I perform a ping test to check connectivity. Since the reply message are received, it confirms that the wireless network is functioning successfully. Part of testing focus on application response times. Here I use packet tracer simulation mode to observe how data packet travel across the network. Shown in the event list panel, this allows us to check communication between devices like laptops, switches, router, and servers. It's smooth and efficient. So by monitoring this packet, we can measure how quickly the network responds, identify any delays, and make sure all configuration are correct.
So let's see the true output testing. Then from pin from PC0 to PC3 successful. Pin from PC8 to PC9 successful. Pin from PC11 to PC0 successful. Pin from PC4 to PC6 successful. Then ping from PC4 to PC6 successful, ping from server 0 to PC4 successful, and PC6 ping to laptop 0 also successful. So let's see the availability testing. All devices were consistently online and accessible, and no connection interruption were detected during testing. So let's see the regression testing. New devices were added in the manager department and have given an IP address. And the new device cannot work functionally in the same department. The structured cabling installation method will be used to set up the network for Cempaka Enterprise. This method follows a systematic and standardized approach to ensure efficient cable management, scalability, and ease of maintenance. The installation will begin preparing the network layout based on the floor plan, followed by the installation of trunking and cable pathways To ensure safe and organized cabling, all Cat6 UTP cables will be terminated at both ends using path panels and wall outlets to support a structured cabling system. The network device such as routers, switches, and servers will be installed in a secure network rack to ensure proper ventilation and equipment protection. Wireless access points will be mounted at strategic locations to provide wide Wi-Fi coverage. After installation, the cables will be labeled and tested using a cable tester to ensure there are no faults. Finally, device configuration, network testing, and documentation will be carried out to verify proper network performance and ensure the installation meets industry standards. Now let's see the implementation plan for maintenance and downtime. A scheduled maintenance plan will be implemented to ensure the network remains secure, stable, and efficient. Preventive maintenance will be carried out monthly and quarterly to update systems, check hardware conditions, and monitor network performance. Any maintenance requiring downtime, such as system upgrades or server patching, will be performed outside of office hours, preferably during weekends or after 8 p.m. to avoid disrupting daily operations. All users will be notified at least 48 hours before any planned downtime. In cases of unexpected downtime, the IT team will follow a standard incident response procedure to identify the issue, apply temporary fixes, and perform root cause analysis. Backup systems will be activated when necessary to reduce service interruption, and all maintenance activities will be recorded for future reference and improvement. Estimated software budget. The estimated budget for software required to support the network operations of Chempaka Enterprise is between 3,500 ringgit and 7,500 ringgit. This includes the cost of network monitoring software such as PRTG or Nagios, which is expected to cost between 1,500 ringgit and 3,000 ringgit to monitor network performance, bandwidth usage, and device status. Additionally, a server backup solution such as VM, Acronis, or a configured async backup system is estimated to cost between 2,000 ringgit and 4,500 ringgit to ensure proper data protection for the HTTP server and to prevent data loss. Estimated hardware budget. The estimated budget required for the hardware devices to set up the network for Chempaka Enterprise ranges from 11,020 ringgit to 18,500 ringgit. This includes essential networking devices such as a Cisco router, 324-port switches, and a Wi-Fi 6 wireless access point to support both wired and wireless connectivity. A network server will be allocated for hosting the HTTP server and managing backup operations. Additional hardware such as a patch panel, network rack cabinet, and an uninterruptible power supply UPS are included to ensure organized cable management and continuous operation during power interruptions. Cabling materials including a Cat6 UTP cable rail and fiber optic cable for backbone connection as well as connectors, facepacks, and trunking are also considered in the budget. Network installation tools such as a crimping tool, cable tester, and punch-down tool are included to support setup and maintenance. This estimated cost provides a practical allocation for establishing a functional and reliable network infrastructure for the company. So let's see the project timeline with Gantt chart. Task week 1 is planning, task week 2 is installation, task week 3 is configuration, and task week 4 is testing. So let's see the last one is conclusion. The proposed network design for Chempaka Enterprise successfully provides a structured, scalable, and secure solution to meet the company's growing operational needs using a hierarchical design, VLAN segmentation, and proper IP subnetting. The network ensures efficient communication between departments while maintaining security and manageability. The use of Cat6 cabling, enterprise-grade Cisco devices, and reliable monitoring software guarantees stable performance for both wired and wireless users. Prototype testing verified that all configurations function as intended with full connectivity and consistent network availability. The implementation plan, budget estimation, and maintenance schedule demonstrate that the solution is practical, cost-effective, and sustainable. Overall, the network design achieves the project objectives and supports future expansion for Chempaka Enterprise. So that's for all. Thank you.